Hello everyone, my name is William and welcome back to Unity, making a 2D platformer in Unity. And I'm sorry guys, but I won't be able to show you how to make a wall jumping system, but I'm sure it isn't very useful for most of you. However, I will show you something that is very useful, and that is how to make players. I mean, not the players, enemies. Now, you're going to probably need a lot of enemies in your game, but it really is up to your personal platformer. But here I extended the ground a little bit, so we have enough room for an enemy. So now let's create one. So let's create a new. Let's just go to pre-art, take an enemy, put it here, and then see it's small, so we have to increase the size of it. So let's do 2 and 2. Put it down here. Then let's go here and add a circle collider 2D. Let's add a rigid body 2D. This will be very similar to the player, by the way. And then we're going to create an entirely new script and call it the enemy controller. Attach this to the enemy, and then we shall run and work on the code here. Okay, good. So now we started it, let's edit around, shall we? So first we're going to do some simple movement. Alright. And so the movement's going to be very similar to the player, so let's do public void movement. Then let's do public float speed, public bool moving left, and let's do private rigid body 2D, RB2D. Now we of course need to get the component of the rigid body in our from our game object, and then the update was called the movement function. Now in the void movement, what we're going to want to do is we're going to want to do a simple code to make sure that we can move it. So let's do if moving left. If we're moving left, and what we're going to want to do is we're going to want to do rb2d dot velocity is equal to new vector 2 negative speed, because left is negative, and then rb2d dot velocity dot y, because you might want your enemy to have some jumping or something. So else, if that's not the case, then we're going to want to do rigid body 2D dot velocity is equal to new vector 2 speed, and then rigid body 2D dot velocity dot y. And good. So now let's test it, and then we're going to explain what the conundrum is. Now let's set the speed to 2, then let's play. And as we can see, the problem is it moves, but it stops here. But what we wanted to do is we wanted to hit this object, this cube. Then we wanted to move left, and then hit this place. And then if it's hit an edge, we want it to move back again. So we're gonna have to code that inside, but it's the same system as the player, where we have left and right checks using rays. So let's create a new empty object, call it left check. And then let's set it to the same position, so negative 0.125. And then let's duplicate that, right check, and then let's set it to positive 0.25, and then let's set both of these. Let's add a little yellow dot to each of them. Now it's going to be the same system as for the player when we're checking the ground, but instead of checking the ground, we're also going to check whether it's here, so whether it's off the scale, I mean off the edge, or whether it's whether it hits another cube on the right. So what we're going to want to do is we're going to want to make an entirely different function, do public void check grounded, or just check, whatever you want to call it. And then we're going to create some more variables. So this one is for movement checks. Then we're going to want to do is we're going to want to make quite a few variables. So public game object left check, public game object right check, public float ground distance, public float wall distance, because the wall distance is different from the ground distance, then public layer mask ground, and then the public bool left grounded, and public bool right grounded, in case you want the player to, in case you want him to jump, of course. And so, I mean, this is for jumping. We're not going to make the enemy jump, but it's up to you, of course. So, if we want to check the grounded, and so here we want to do 2 raycast hits. So, raycast hit 2D hit left is equal to physics dot the physics 2D dot raycast, and then we're going to want to do left check dot transform dot position, and then the vector 2 dot down, then ground distance, and then ground as a layer mask. Of course, very similar to the player ground check, but now we're going to do an entirely new one. Hit wall left, which will check if we're hitting the left wall. So physics, and we're just going to essentially copy and paste this. And we're going to do the same, except for vector 2 dot down, we're going to do vector 2 dot left, and then we're going to do wall distance. And so here we're going to have a check here. So if you're moving left and hit wall left, what am I doing? I'm not looking at it, sorry, and hit wall left dot transform is not equal to null. So we're moving left and we hit a wall. Then we're going to want to do is moving left is equal to false. So we're going back to moving right, and if hit left dot transform is not equal to null. So if we are not hitting a null, then we are grounded. But else, if it is null, then left grounded is equal to false, and moving left is equal to false too. And so let's go back here to the enemy, set some variables. So we want the left check to be here, right check here, ground distance 0.5, wall distance 0.2, ground will be ground, of course. And now let's play. Just said moving left, and then when it hits the left part it should. Okay, it doesn't do that. But hold on, perhaps we need to do some checks here. Oh right, we didn't set in the update function, so let's do check grounded. Sorry about that. Let's set moving left to true, and let's play. As you can see, that's what happens. And now we're going to want to do the same thing, except for right movement. Hit right, hit wall right, vector 2 dot down, vector 2 dot right. If moving, so if we're not moving left, and hit wall right dot transform, then moving left is equal to true. And then if hit right, then right grounded, well, you get the deal. There we go. Let's test it out and let's see what happens. No. Sorry, this is having me. I'm having some problems here. Oh, we have to do right check here. What am I doing? There we go. As we can see, the wall distance is maybe perhaps too small. So let's maybe do a 0.05. Hello everyone, it's me back again, and I've messed around with this quite a bit, and I had to cancel the recording, but I found a glitch which is in both of these, and that is that if you look at the constraints in the Rigid Body 2D, you essentially have to type freeze rotation, and you gotta type Z. And the reason why you have to do this is because if you don't, then look what happens if you don't do this. As you can see, it's rotating crazily. That's why you need to put the freeze rotation Z here. Then when we do so, look what happens. When we do this, look, the player is the enemy is moving correctly like how it should. Anyway, that's it for this tutorial, and I'll see you in the next one. Bye, guys.